And welcome to Ladyada.
Hey everybody, and welcome to my desk. Another Sunday night, another week of engineering and fun. We're not at CPAC, instead we're at my desk doing engineering, which I think is probably a better use of my time. A lot of stuff came in. First up, is there any news or updates we want to tell people about?
No.
Great.
Regular show schedule this week.
Yeah.
So,
Yeah.
see you on Tuesdays, Wednesdays, Thursdays, and Fridays for all of our shows.
Yeah, I think Scott is either Thursday or Friday. I don't remember. We'll find out later this week. But
I think he's Thursday this week.
Thursday this week. Okay. Well, let's jump right into some of the stuff that I got. So let's go to the overhead, and I'll just do samples and stuff, things that we came in. Okay. First off, we actually got some compute boards in. This is the Raspberry Pi 4 compute module boards. It's pretty cool. They're in stock, but I also grabbed them for myself because I thought this would be really neat for if you want to do in development with PCIe slots or multiple displays or cameras or it looks like there's a real-time clock module, chunky HDMI. This is a kind of nice little dev board that I might use for sometimes when I'm doing Raspberry Pi projects, and then you plug modules into them. So this is the little module. We also got one of the ones with Wi-Fi, so I'm going to very carefully pry this up. So this is the 2 gigabyte with Wi-Fi module. So these are starting to come out. I think we only have the non-Wi-Fi in stock. I think we only got a couple of these, so I snagged one. But it's got the onboard flash, it looks like. So the MMC Pi 4 chip, Wi-Fi, Bluetooth, and little antenna dongle. So you can either use a built-in antenna, or there's you can see a little built-in antenna, or the dynamic antenna switcher, and use a UFL. So good stuff
the
there.
Audience.
Yeah.
Did you do anything with that ESP32 from last week?
No. I haven't sent out PCBs, but I want to finish that ESP32 Cutie Pie and send it off. I've been actually focused on RP2040 and a couple other things that just business things. This part of the year when you run a business is quite busy because there's taxes and end of year stuff and reporting, and it's a little busier. My time sort of starts freeing up a little bit in April and May, so you'll see not as fast on the hardware in first few months of the year, but that's okay. Plenty of time in the summer to do more. So this is the Compute I/O board, so cool stuff. Check these out if you're interested in doing compute module hacking. These will be available in the shop soon. So good. Okay, next up, I got some cellular modules. I thought I'd just show these off. So these are BG95s. These are Quectel modules. So I used to use SimCom only modules, and I've also used U-Blocks. But Quectel offered me some samples, and I'm not going to say no to some samples. So this is, I got the BG95 M3 and the 95 M1, which is pin compatible. I think one is probably Cat M1, one's Cat M3. We got the EG91. I don't know the difference. I'll check those out. And what's cool is that these come with a removable top. So this is the module, and then the bottom has kind of your funky cellular module pinout. These aren't too bad actually. I mean, the pitch is wide enough that I've never really had a lot of difficulty with these unusual module pitches, like the pinout collection. There's plenty of space here to have via, so these pads, you can via them down to another layer, and these pads come out. So it's actually a pretty easy module to use. And then the tin comes off, and you can see, I think it says a Qualcomm chipset over here, and then some supporting chipsets. So it's a Qualcomm module. Pretty cool. So I've seen the BG95 used a lot, and check it out. I don't think... Yeah, it's a little bit too big to fit on a Feather, which is a little sad. But it could make for a little breakout board, or maybe a shield or something, because 2G is basically over. We dragged out 2G as long as we could. Now we got to move on to LTE. 3G was always, kind of expensive and a pain. But I'm thinking, let's just move straight to LTE. maybe, Cat 1, machine-to-machine stuff. The only thing I hope is I think that these might have an audio interface. I really wanted to have a module that could do audio because people really love the making DIY cell phones or DIY phones. And I noticed a lot of 3G modules started dropping the audio interfaces. So cool stuff.
Is it 3G, LTE? What's...
This is LTE, I think, but you could look up the datasheet, if you want to be sure. I believe it has 2G fallback, and I think this is an LTE module. So BG95. So cool. All right, so this is good stuff. I want to get back into doing some cellular. I know I haven't done cellular in many, many years. It's always a little bit of a journey. Okay, so what else? Okay, next up we got Feather takes flight with the Feather RP2040. Hold on, let me maybe give this silkscreen some... That's on. You can do it. Okay, give the silkscreen some love because Phil B did a beautiful job. These are the this is the array panel of the RP2040 Feather. This is the logo that Mr. Ladyada thoughtfully asked for, and they're like, "Oh yeah, we should have a logo." And so they provided a nice silkscreen friendly logo. You can see a little pie logo and then RP2040. So we put that on the back. The back has the GPIO pins, so we wanted to make this Feather compatible as much as possible with our existing Feathers. So on the front side, we use not GPIO pin numbering, but digital pin numbering, and this is sort of similar to how Arduino does. The original Arduino, the 32U4 and the 328, pin 5 was pin 5. But then what's cool about when they moved on to the SAMD21 and other chipsets is they started to have like a pin table. So, pin 13 wasn't necessarily GPIO 13. There was like a remapping table that would let you map a GPIO number to an underlying pin definition. And this was handy because, if you want to have your boards have pin 13 red LED, right? That's kind of a standard Arduino pin number for the red LED. You may not actually have a pin 13 on your chip. Like some chips don't even have 13 pins, right? Or that pin 13 might be used for something else. GPIO 13 might not be available. But with pin remapping, which is a wonderful invention, any pin can be numbered anything. So what we did is, in CircuitPython, we definitely have pin remapping. Like, GPIO 13 on this board happens to be 13, but like 5 is not. I'll explain in a moment exactly why. 5 isn't GPIO 5, but in CircuitPython, we do that remapping for you. So when you interface with D5, it's going to be, I think it's GPIO 7 or 8 or something. But for those who are going to be using this with pico-sdk, and the pico-sdk, I think they haven't added pin remapping yet, you have the low-level pin numbering. And so the reason, if you're like, well, why aren't the pins in exactly the same order? The reason we did that is we wanted to have pin 13, these 8 pins here, 13, 12, 11, 10, 9, 8, 7, and then over here 6. We wanted them to be in a row. And what I mean by that is the 8, free GPIO pins, not I2C, not UART, not SPI. They are consecutive GPIO pins because the RP2040 PIO state machine system works on consecutive pins, and so the most number of pins you can work on is 8, and so this means that there's if you want to use the PIO for some like funky like data pushing thing going on, you would be able to do it and have as many pins as possible in a row. So there's like, if you're trying to like say drive 8 NeoPixel strands at the same time in a row, you can do that. But I didn't, I wanted to make sure that our existing Feathers and feather wing examples worked well, and so that's why we made the pin numbering up here, 5, 6, 9, 10, 11, 12, 13. That's kind of the standard Feather pin numbering order. So that explains that. So that's why the pins are different on the other sides. Otherwise, this is a nice board. What's nifty is that even though the RP2040 is a 0.4 millimeter pitch part, really haven't had any issue with assembling it even by hand. So, I put together, you can see there's 2 missing. I put together one of them over here to test it out, and it's just running a NeoPixel, swirling demo and blinking the red LED. So once we have the board designed, as people who watch the show know, I have to make the tester. And my favorite testers are Teensy-based testers. We do use Raspberry Pi computers for testers sometimes. The cool thing about a Raspberry Pi is it's a computer. So you can plug a J-Link into it or run OpenOCD. You can run software.
That was a question. That's what I was asking that I'll...
Okay, why don't you ask the question now?
Will the Feather be debuggable with OpenOCD and GDB like Pico, or will we need a different technique?
You can. I didn't break out the SWD pins like on GPIO pads. They're available on the bottom. There's 2 pads down here that you can barely see. It says clock and data. These are the SWD pads. But there's also, if you are somebody who really wants to do debugging, and if a lot of people demand it, I'll do it. There's an SWD connector that you can solder in place, and that will use the standard SWD connector. Why not have it broken out into pads? There just wasn't room. I had to choose what I wanted to have, and so in the end I was like, I think an SWD connector is more useful. Time will tell. Look, if turns out absolutely nobody ever uses the SWD connector and they want breakout pads, I'll respin the board, right? No big deal. There'll be more room even because the SWD connector is quite large. And if people really demand it, I'll make a version that has that part placed. But for now, I'm leaving it blank because honestly, not a lot of people do SWD debugging, right? It's for some engineers, and for those engineers, if you're doing that, you're also the kind of person who is comfortable soldering on a connector. But speaking of, when we make boards with other Cortex chips, like the NRF52s or 51s or STMs or SAMD series, we program them over SWD. And I was kind of planning on doing that as well. I was like, okay, well, at worst, I can always connect up to a Raspberry Pi and then use OpenOCD on the Raspberry Pi to, connect to these pads and then load firmware that way. But what's interesting about the RP2040 is it has a ROM bootloader, and the ROM bootloader is UF2, and that means it's a disk drive. And I was talking with TAC, who is our developer who works on TinyUSB and also has been helping maintain our SWD DAP, our self-contained programming software for Cortex boards, like Lighten boards, program boards. And he basically said, look, there's this multi-drop thing that the RP2040 is doing, and it's I don't really have time to look at it, and it's a little bit more complicated. But what we could do is we could use the USB host capability of the Teensy 3.6 and mount this as a disk drive. Literally, put it into bootloader mode and then access it like a disk drive and then, copy over USB the firmware. And we actually got that working, which was pretty cool. So here I've got my Teensy 3.6, and then I've got it connected to a USB socket over here. So you can see this USB socket, and then I have a USB cable plugged into it. And the other side of the USB cable is over here. And all I have to do is connect the, all I have to do is I have, just for now, I've soldered the boot pin, because you do need to use the boot pin to get into bootloader mode. I don't want people to have to press the buttons. Instead, I just have a pogo pin on the final tester wired to this GPIO. And then if we go to my computer, I have here this Teensy serial monitor, and I'll just reload it. And you can see how the tester works. It uses the SD card on the Teensy. It loads a UF2 file from it called 4884test.uf2, and it literally copies it over the USB interface to the RP2040, thus loading the firmware. And in this case, it does it about 100K per second, which is super nice and fast. And as a side benefit, this also lets me really test, the bootloader and the USB interface. It's kind of I like it when tests test multiple things, because it's I'm testing programming, I'm testing the flash, I'm testing the USB, I'm testing the bootloader, like, ooh, so much testing going on. And then the test program itself was written in pico-sdk. I normally write them in Arduino, but Arduino's available yet. When Arduino's available, I'll do that. So I thought I would show the feather test real fast. Looks like XEMX doesn't let you make the text larger.
When you're done with that,
Yeah.
we'll do some questions.
Okay. Well, basically the test program, what it does, and maybe I'll publish this somewhere, is it actually has the NeoPixel swirl going until it receives a character on the UART, 0xAF. And if that character is received, it breaks out of the like NeoPixel swirly loop thing that's going on here, which is just a NeoPixel color wheel, and it then does some GPIO pin testing, and what I do is on the tester I have pogo pins that connect different pads together, and I verify that they're connected but nothing else is connected, basically just making sure each pin is connected to the pad it's supposed to be. And if so, it checks the ADC and makes sure the voltages are correct as well. And then on success, it does a printf and I'm done. So what's interesting is that if I have this board and I connect the RX and TX pins and I send OXAF, and you saw like it starts doing the test procedure. Like you have to trigger it with the special character, and that tests the UART, and then on the receiving the special character, it stops the NeoPixel and then goes into test mode. So what's nice is that I can program this test and ship this test firmware, and people who are getting it aren't going to know it's actually test firmware. They're going to be like, oh look, the NeoPixel swirling, ooh, like this is the demo. It like runs. I know that the hardware is good. They don't need to know that that's also the test firmware. So that's our little secret, But what's nice is that it means that I can program and test everything in about, 0.64 seconds per board. So the entire test takes 2 seconds, and that's like, for me, awesome. I love it when testing takes less than 3 seconds.
Nobody shows how anything is tested, how any of the software is made, none of the things that you need to do, testers make testers. We do that. We've been asked in the past, like, you're worried about your competitors being able to test things better, easier, and I say that is exactly why we release it, because what if we all got better at this? What if we all shared stuff? But someone has to go first.
Okay. So that's the good stuff. So, basically taking, getting rid of the Raspberry. I love Raspberry Pi computers, but believe me, if you're making testers, you want them to be as solid state as possible. You don't want Linux involved if you can avoid it. And this is just a drop down and test in 3 seconds. It's going to be awesome, especially when we do the cutie pies. I want to keep those as cheap as possible. And test time is, that counts towards how much it costs to manufacture something. It's how long it takes to test. If it takes 3 seconds, that's awesome, right? That it's a lot less expensive than 2 minutes.
Okay, you want to do some questions?
Yeah, let's do some questions.
All right. Yes, that's the RP2040 Feather from before.
Yes.
Next up, what's the diameter of the mounting holes, I guess, in the previous boards?
I think they're 0.1 inch.
Okay, suggesting to look at the Blackmagic Probe SWD header. I guess they make smaller ones.
Look, I know that there's people who do like funky, cool, weird, like, ooh, it's tag connect. Okay, great. Classic 0.05 inch 2x5. Never go wrong with it. If you can fit it, I put it on
Next
there.
up, does Adafruit test and program the boards one by one? Yep.
Yeah, we do. Every single board is hand tested.
And how does the pick and place machine pick up one of those SWD connectors? Is there a tape over top like some of the USB and an insert?
It looks like Jeff posted a photo. There's a little cap, and if you actually have a board where we don't use the SWD for testing, you'll see the cap is still on. It's just removed. Okay. So
longer question. You want to leave this one for the end?
No. Let's get
could Limor talk about failure? It seems like it's a really important part of making creating, and Limor makes it making it seem really easy. It would be amazing to see her process for working through something that has had her stumped.
Yeah, I don't usually do those kinds of streams, mostly because they just take a little too long. They're actually really hard to do. So I usually try to get a bunch of things set up for Desk of Ladyada. We do blog posts about debugging process, and Scott's videos streams that are 2 hours long go into, deep development and debugging at the same time. If you want to see like the development process, where I make like mistakes, decisions, and then I change my mind, check out the Maker to Market series. We did a 10 video series where like I go through decisions, some of which are good, some of which maybe I made mistakes.
Okay. Any chance of a RP2040 with a BTLE I2C stemma on board?
I think you could pair the RP2040 with an ESP32, coprocessor, and I was thinking about doing that for like my Metro design, but I just haven't had time to keep working on it.
Yeah. Folks, a couple of people want to see the test code, so if you want to post up there.
Yeah, I'll publish. I'm not gonna have time tonight, but I will publish it somewhere.
Okay.
For sure. So one thing that I still have to work on, like, and I discovered this like today, is my prototypes used a 2 megabyte flash, and I was like, for the final version I want like 4 or 8 megabytes, and then I realized that you can't just swap the QSPI flash. Turns out that I knew that each QSPI flash chip is different, but when you program in the pico-sdk, you do pick the trying to remember the secondary boot stage 2 file, and the stage 2 file is what defines. It's really annoying. Like QSPI flash is like almost completely identical from board to board, but like the status register and the Q enable, the quad enable bit, it's like different and whatever. Like you actually have to like do stuff to make it work. A little frustrating because it's like they're all pin compatible. And they're kind of functionally compatible, but the details of them are not compatible. So turns out, you have to set it into generic mode. And even in generic mode, the 4 megabyte didn't work. So bonus, the Feather is going to ship with 8 megabyte instead of 4 because I just don't feel like sitting down and figuring out why the 4 megabyte chip isn't working. I'll figure it out later. But for now, I think I'm just going to bump the Feather RP2040 up to 8 megabytes because we stock the 8 megabyte. I know it works, and I got, the test works under 8 megabytes. But that was definitely, if you're working on your own hardware, like that, watch out for like the QSPI flash chip. It isn't like drop anything you like. The default files do work with the GDQ25, which GD25Q32, which is a 2 megabyte gigadevice flash, which is like one of my favorites. It's on a lot of boards, and so luckily I think our default flash was also worked with the default files, but turns out that's not true. So hopefully I'll just save you like the 2 hours that I lost trying to figure out why the heck one board with 2 megabytes was working, but the board with 4 megabytes was not. All right, so that's that. So expect the Feathers, unless something tragic happens. We'll at least be manufacturing them this week, and they should be in the store soon. Especially if Scott can help me get the 8 megabyte working in CircuitPython. Okay, and then last but not least, we also got the, can you go back to the overhead, please? We've got the ITZYs. I put these together, so this is Rev B, but I think this is the final Rev. They need a nice silkscreen, but these do have like, the quote unquote standard itsy bitsy pinout, which means at the bottom has the SWD pins broken out like this. So a nice little ground plane, not too bad, right? Got a nice smooth continuous ground plane there as much as possible. So yeah, this cutie will also get wrapped up shortly. Got 2 buttons over here. Got the little NeoPixel RP2040 in the middle, QSPI flash over there, lots and lots of GPIO. And if you want LiPo, you can put a LiPo backpack on top. And then the last thing I worked on is the NeoTrinkeys. I don't know if people remember these from like a couple months ago, but I finally
While we're here, are we going to keep the micro USB on ITZY, or are we going to go to C?
I want to keep it micro USB, and the reason being, all the ITZYs are micro USB, and I kind of wanted to maintain consistency. I mean, I guess I could change it, but I kind of wanted to keep it the same. So like physically they're the same and use the same connector. The feathers I'm not as picky about because like so many people are making feathers that there's no guarantee of any component height or connector end, and people were starting to make USB-C. But for the ITZY, I'm still kind of heading towards micro B land. I think I'm going to stick with it. We'll see. You know, I can always respin the board, right? That's something you have to keep in mind. So the NeoTrinkey, we want to make a very low cost CircuitPython board with 4 NeoPixels and some capacitive touchpads. Sort of like I was like inspired by like the FOMUs and the COMUs and TOMUs and all those OMU boards where they're just like little USB keyboards with a little capacitive touch. So this is a split touch. You can kind of see here there's a little line in the middle. So there's 2 pads, left and right, or top and bottom, and they're split. They're split in the middle. Kind of hard to. Yeah, you can kind of see. So it'll be gold, not silver, but you can see how the middle is disconnected, but there's a little keychain slot. And then these are, standard thickness, so I just blobbed some solder on them to make them thick enough to work. And then one of these, I don't know which one. Yeah, so it's got, this one has just, I think, green LEDs. One of these has a CircuitPython demo on it, but I don't remember which. Maybe neither. Sorry. But you can kind of see the maybe I broke them. Who knows? Anyways, so yeah, they got 2 capacitive touch pads. You can see the NeoPixels, like now they're green, but they can of course be any color. Got a reset button, a little regulator, just enough capacitors and parts, like the minimal parts to get this SAMD21 up and running. Let's see if I can figure out. This is in bootloader mode. Maybe it is this one then. Oh, there you go. Oh, sorry, so this is the demo. So this one, they can change the brightness, and then on this pad, when you touch this pad, it changes the color. So you can see a little color swirl, and then this is like bright, and then back down to not so bright. So this is a little color demo, just showing the 2 capacitive touch pads. So I just showed a bunch of RP2040 stuff. Why didn't I use the RP2040 for this board? Why stick with the SAMD21? Well, I mean, when you want to talk about like minimal parts, not cost, right? Because the cost is it includes a lot of things, right? Manufacturability and excess components. So the RP2040 does need a crystal, and it needs external flash. It needs a lot of capacitors. Whereas what's nice about the SAMD21 is it's not as fast, but it has like flash built in. It can has an internal resonator that can be phase lock looped off of the USB, so it can be more precise stuff for NeoPixels, which is all I really care about. It doesn't need like a pull up on the reset. There's a lot of parts that you can leave off on the SAMD21. It's like a very like happy with the least type of part, which I think is cool. And so there's a place in my heart for both of them. And speaking of which, I thought people will probably want to use the SAMD21. They might be asking, well, there's so many different kinds. Which one? How do I know which one to pick? And how do I find them on DigiKey so I can include them in my design? So that sort of leads us into the Great Search.
All right.
Where in the world is that part I need? The Great Search with DigiKey.
Every single week, DigiKey and Adafruit bringing you the Great Search. Ladyada, what is on the Great Search this week?
Okay, so this week I just showed off my NeoTrinkey. It's a little SAMD21 based board. I still really like the SAMD21. It's a great chip. It's used, in Arduino and CircuitPython and Rust, Zephyr, FreeRTOS. I mean, like, you can program the MicroPython. You can program this in like so many different languages. It's a really nice, solid chip, and it can run with really minimal hardware. I thought it would be cool to show all the different variants you can get on DigiKey, how to select between them. I don't think we've done a microcontroller yet, so I thought this would be a good first microcontroller for the great search. So let's go over DigiKey. And we'll do our search in. Okay, so let me scroll around. Okay, so the SAMD, so there's the SAMD21, and then there's the SAMD51. The SAMD51 is the Cortex M0 family. It's kind of a different chip, although it shares a lot of the same peripherals. There's also the SAM-C and SAM-L series, which I won't be talking about. The SAM-L is lower power, but is very similar to the SAM-D in many respects. The SAM-C is interesting. I think the C stands for CAN bus. It's a 5-volt version of the SAM series, but it doesn't have USB. So just watch out for that. Like if people are like, oh my God, there's a SAM-C21. Why don't you use that? It's 5-volt compatible. Yeah, but it doesn't have USB. And one of the things I like about the SAMD21 is it has USB. So let's look at SAMD21. So, of course, we sell tons of boards that have the SAMD21. So, you can get OLEDs, breakouts, whatever, evaluation boards. You'll get your feathers there. But we want the microcontrollers. Okay, so as usual, let's only look for active parts. And note that, again, some of them don't have USB, maybe, I don't know. But the thing that you really want to look for, there's only like 3 different things that you can pick. The size of the chip, the amount of RAM, and the amount of flash. Now, like most microcontrollers, they're kind of tied together. The lowest pins usually also have the lowest flash and the lowest RAM, and usually you can't independently pick flash and RAM. Like, the more flash, the more RAM. You can't have something with like a ton of RAM and a little bit of flash. It doesn't work that way. Like they kind of go in lockstep. So it's just as long as you're aware of that. So you can pick the amount of RAM and program size, program flash you want from 32K up to 256K. And you're pretty much paying for those 3 things. You're going to pay for more pins, you're going to pay for more flash, and you're going to pay for more RAM. So, a common thing is you design with the biggest version of the chip, figure out how much flash and memory your project took, and then when you go into production, you just round up to the closest one that will fit everything you need to do. But having it all be pin compatible makes it really easy to move between the families. And then, of course, if your product or your project grows and increases, you can always start bumping it up. So that said, another thing to look at is the package and device. So, in my case, I wanted the physically smallest one. So the WLCSP is going to be literally the smallest one, right? This is tiny. It's only 2 by 2 millimeters. That said, it only has 32K of flash or 64K of flash, these 2 versions. And that's not enough for me. I actually want to be able to run CircuitPython on these. I need at least 32K of RAM and 256K of flash. But still interesting to see. Microchip, they kind of always have like a teeny BGA version and then QFN and then go up to QFP. I kind of like QFN the most. Like if you had to pick one package, I like QFNs. Why do I like QFNs? Well, QFPs, they have more pins, but the pins get bent sometimes, especially doing rework. I've always had like the most yield success with QFNs. But, talk to your manufacturer to decide what package you want. So of the QFNs, there is a bunch of different versions. There's the 21Gs, the 21Es, Js, 18s, and all those characters, stand for different variables that you can adjust. So the E, when it says SAMD21E, the E stands for 32 pin. And then the G stands for 48 pin. And the J stands for 64 pins. That's the biggest you can get of the SAMD21s, the 64 pin chips. So, physically the larger they get, usually the more pins you want. So you can pick the E subcode if you want just the physically smallest QFN. And then the digits afterwards, like the 17 and 18 and 15, Those stand for, is it 15? The 15, those stand for how much flash and RAM. And like I said, the flash and RAM on these chips kind of go in lockstep. So let me close my, actually let me just open up the data sheet. In the data sheet, you will see a ordering information page, and you'll want to use this. This again tells you pin count is this letter code, and then flash memory is the number code. So in our case, we want 18. We want the most flash memory, and we want E for the smallest size. So smallest, sorry, I'll scroll up. Smallest, physically smallest, but memory-wise largest. And then there's silicon revisions. You know, there's variants, but basically you're only going to really see the A variant unless I guess they made them for some special customer or something. But in our case, the variants, we don't really see any other options. And then the -MUT is for the package, again, QFN, QFP, or BGA. And then the package grading, how it's packaged, and the temperature grade, and then whether it comes in tape or in tray. So, but that doesn't matter for me as much. So again, I want to have the 256K of flash, and I want the smallest number of IO. And that's what I got. So I've got a couple different options. The MFT, you know, these are all SAMD21 E18s, but they come in MFT, MU, MF, MUT, and MF, right? So you're like, what's the difference? Go back to the data sheet, and you can quickly tell, okay, they're all M, so that's QFN, and then the U or the F just stands for whether it's 40 to 85 or 40 to 125. Basically, is it industrial or is it commercial temperature level? You probably don't care, or at least I don't care, right? It doesn't matter to me whether I'm getting industrial or commercial temp. So that's when I would basically put in, you know, okay, let's see the pricing at 1,000 pieces. And I just pick the cheapest, right? Which in this case happens to be the commercial temperature range tray. This is the one I like, the MU series. But again, you can also get the MUT, which is like, you know, basically the same price. It's like 6 cents more. The nice thing about this version is it comes on tape and reel, which, you know, might be beneficial for you depending on your manufacturing. Our machines take tray or tape very well. They don't like tube. So just, you know, if you go into manufacturing, just check with your manufacturer to see how they want the chips packaged. But that's it, the MU series. So this is the chip I like. I use this in the Gemmas, the Trinkets, NeoTrinkey. This chip is awesome. It's really easy to use. It's easy to load it with our UF2 bootloader, and there's bootloader protection. Once you put the bootloader protection, it's pretty much, you know, nearly indestructible. It's very rare that we've seen people frazzle their bootloader. It's nice and solid. And then you can load Arduino or CircuitPython. And, you know, for the size and price, it's quite powerful. It's 48 megahertz, 256K of flash, 32K of RAM. So good enough to run some basic CircuitPython code or quite a bit of Arduino or Rust or Zephyr code. So that's my great search at SAMD21E18.
Where in the world is that part I need? The great search with DigiKey.
All right,
Lovely card.
Desk of Ladyada, there was one question that was in the other chat. Was that the, can you show the Trinky?
Trinky.
Overhead, they joined late, they want to see it. So
Trinky.
yeah.
So it's got USB. It's got blob solder to make it thicker because I got, you know, the non-thick PCBs. It's got the SAMD21E18, a little power supply section here, capacitors.
Yeah.
We
We'll have it in
buttons.
the stores, either coming soon or it'll be for sale soon.
Yeah, in the 4 NeoPixels. So, NeoTrinkey. I don't know, he's a little catchy theme song.
Yeah.
Okay, that's all I got.
And that is Desk of Ladyada for this week. We'll see everybody during the week on our various shows and more.
Thanks, everybody.